Hello there, Mr. Sutton here, bringing you the Algebra 2 7.5 lesson on solving rational equations. This will be a two-parter. In part 1, we're going to be solving equations by cross-multiplying, which you may have done before, and we're also going to use this to help us find some inverses of rational functions. And then in section 2, we'll check out the technique of solving by using the least common denominator. So here's our opening problem. They want us to solve this equation right here. Now, this is an example of what we call a rational equation. A rational equation is one that has a variable or variables in the denominator. There's lots of equations that have fractions in them, but if the variable's in the denominator, that makes it a little extra special. So our strategy on all of these problems is that eventually we need to get that variable out of the denominator in order to solve for x. And there's a few different ways of doing that. The strategy we're going to look at in this first example here is that of cross-multiplying. You can use this strategy when you essentially have two fractions with an equals between them, or at least an equals and at least one fraction on either side. So the whole setup here is you kind of have an a over b equals c over d situation, and you can just multiply the denominator of one side by the numerator of the other side, and just do that for both sides. So this ends up being a times d on one side equaling b times c on the other side. So this will get any variables out of the denominator because there won't be any more denominators. Now, before you go ahead and solve this one other thing you're going to want to make sure on all of these rational equations is you need to check to make sure your solutions don't make the original equation undefined. Sometimes you might get an answer that when you plug it back in gives you 0 in a denominator. So always check for that. With all that said, pause the video and give this one a shot. All right, let's see how that went. So using cross multiplying, because we just have one term on each side, we've got 3 times 4x plus 5. That's the AD part of this. And then on the other side, we have 9 times x plus 1. So now we just have to distribute. This is basically just a normal linear equation at this point. So we've got 12x plus 15 on the left, and on the right side that's going to be 9x plus 9. Moving the x's over to the left, 12x minus 9x gives us 3x. Subtracting 15 over to the right side, 9 minus 15 is going to be negative 6. And then dividing, we get a final answer of x equals negative 2. Or do we? Remember, we have to check to make sure we don't have any extraneous roots that we came up with by good algebra, but it doesn't actually work when we plug it back in. So if we plug negative 2 in, negative 2 plus 1 doesn't give us 0 in this denominator, so that's fine. And then 4 times negative 2 plus 5 is not going to give us 0 down here either. Negative 2 doesn't make anything undefined, so it's a good answer. Here's another example for us to try out. Same kind of idea, but a little tougher on the back end. Pause the video and try it out. All right, so again, we've got one term on each side, so cross-multiplying will work in this situation. So we've got on the left side x times x minus 1, and honestly, it doesn't matter which side each of these goes on as long as you're cross-multiplying. Now on the right side, we've got x minus 5 times 2x plus 7, or vice versa. Again, the order doesn't really matter if you're multiplying these. So let's go ahead and distribute everything. On the left, we've got x squared minus 1x. On the right side, foiling this out, we've got 2x squared plus 7x minus 10x minus 35. And since we've got a quadratic, let's try to get everything on one side and zero this thing out. Maybe we'll be able to factor it. Who knows? So I'm going to move things over to the right side so that I get a positive x squared. 2x squared minus this 1x squared is giving me another 1x squared, so that's a good sign. And then on the right side, we have 7x minus 10x, which is negative 3x. Adding another x over there is going to give us a negative 2x. And then finally, we already have this negative 35 over there. So all that equals 0. This definitely looks like I could try to factor it. Let's see here. Things that multiply to negative 35 and add up to negative 2. 1 and 35 doesn't work, and the only other option is 5 and 7. Thankfully that works if you have a positive 5 and a negative 7. So x plus 5 and x minus 7 equals 0. Let's go ahead and just zero each of these parentheses out now. So we've got solutions of x equals negative 5, and for this next one, positive 7. Just double checking my answers. If I plug negative 5 in, 2 times negative 5 plus 7 should be all right. Negative 5 minus 1 is also not 0. And then plugging in 7, that doesn't make anything undefined either. So these are both acceptable answers. For this next problem, if you're taking the CP non-honors version of the course, feel free to skip on to the next one. If you're doing the honors, then let's tackle this one now. So we have an alloy formed by mixing 2 or more metals. This is a pretty common thing. You might have some jewelry. Sterling silver, which some of your jewelry might be made of, is an alloy composed of 92.5% silver, 7.5% copper by weight. And then let's say that you have 15 ounces of 800 grade silver, which is 80%. So we're learning new stuff right away here. And then 20% copper. We want to know how much pure silver we should mix with our 800 grade here to make sterling silver. So the idea here is we're trying to achieve a certain percentage of silver. So it might help to have a formula that talks about the percentage of silver. The percentage of silver is just going to be the amount of actual silver you have divided by the total weight of the jewelry or whatever you're dealing with. So we can say percent of silver equals amount of silver over total weight. And the idea here is we need to now set up an equation using some variables and this information here. Pause the video and just take a moment to think about what you might plug into each of these spots based on the information in the problem. All right, so we're talking about percent of silver. If we want sterling silver, then we're trying to achieve this 92.5%. So for this percent silver part, I'm going to replace that with the decimal version of this, which is 0.925. Now we need to talk about the amount of silver. How much silver is actually in there. So we have 15 ounces of 800 grade silver, but we know that's only 80% actual silver. So we would need to do 0.8 times the 15 ounces that we're starting with. And then we're trying to figure out how much pure silver to add, so let's let X be the amount of pure silver, the number of ounces of pure silver we're adding in. So we can say 0.8 times 15, that's the amount of silver we've got so far, plus whatever we're adding. Now the total weight is going to be the whole 15 ounces that we started with, plus the extra weight in pure silver. So we can write 15 plus x for that denominator. And this now gives us a rational equation that we can solve. Pause the video again and let's see if we can figure out how many ounces of pure silver to add. So the reason this is such a good problem for this lesson is you might recognize we've kind of got a cross-multiplying situation here. Although we don't have a fraction on the left side, we only have a single term, and we've got a fraction on the right. So you can definitely still cross-multiply. It's just kind of half of your crossways going on here. So let's distribute this 15 plus x over this 0.925. And for that, I'm definitely going to take out my calculator. So we've got 0.925, 0.925 times 15, and that's going to give us 13.875. And then x times that is just 0.925x. Over on the right side, 0.8 times 15 is going to be 12. Okay, that's not so bad. So I'm going to get my x's on the left, numbers on the right. It doesn't really matter which way we roll at this point as long as we're consistent about it. So 0.925 minus 1x is going to be what? 0.925 minus 1 is negative 0.075. So we have negative 0.075x on the left side, and then we're doing 12 minus 13.875. That's going to be negative 1.875 on the right side. And then let me go ahead and divide. So negative 0.1 or negative 1.875 divided by another negative 0.075 comes out to exactly 25. So that's going to be 25 ounces of silver. Now that we've learned a technique for getting things out of the denominator and solving, see if you can find the inverse of example 3 here. All right, so just to review, to find an inverse, we have to interchange the x and the y value. So I'm going to rewrite this as x equals 2 over y plus 3. And for this one, to get y out of the denominator, because that's ultimately what we have to do, we could multiply both sides by y plus 3, and then I'm going to immediately divide by x. So basically, this is kind of like cross-multiplying, only you're switching these two things. So we have y plus 3 equals 2 over x. And then just to get y by itself, we can just subtract 3. So that'll be f inverse of x equals 2 over x minus 3. All right, so let's try out now this next problem on finding the inverse. Did you immediately switch x and y? Well, you might want to hold off on that because there's a even exponent in this denominator. Now you might remember that when we have even exponents, that actually removes our ability to find an inverse, because if I plug in negatives or positives to an even number, I'm not going to be able to kind of backtrace and figure out which I plugged in if I go the opposite direction. So because of the x to the 6th, this is no inverse, and we just stop right there. And with that, that is the end of part 1 of this lesson. Pause the video, try out some of that cross-multiplying and inverse fun, and then come back and we will take a look at another technique for solving all these sorts of problems using least common denominators. Welcome back for part 2 of this lesson. In this one, we're going to learn a new technique for solving these sorts of equations. So again, our overall goal is to get the x, or whatever variable, out of the denominator. And one way of doing that was cross-multiplying. Now you might notice that's not going to work so well in this situation because we have two terms on the left side. So one kind of workaround for this is to find a common denominator and merge this into one fraction, and then you could cross-multiply, and that would be just fine. Another way to do this that's a little bit faster though is actually just to find the LCD and multiply all the numerators by that LCD. The reason this works out so well is because the LCD is divisible by all the denominators. That's kind of how we built it, is by taking the factors of the denominators and throwing them all together into this LCD. So if I multiply all the numerators by the LCD, if I have something that's divisible by all the denominators in the numerator, that's going to let me cancel out all the denominators. And that's another way of getting, rid of those denominators. So with this in mind, pause the video and try this approach out on this problem. All right, so let's figure out the LCD for this. So we have a 4 that we want. That's the only constant. We also have this x, and that's it. We have at most x to the first power in a denominator. So next up, just like we said here, we're just going to multiply all the numerators, all the terms really, by 4x. So 5 gets a 4x, and 7 gets a 4x, and 9 gets a 4x. Let's go through now and cancel out everything we can. This first fraction, we can cancel the x's. In the next one, these 4's are going to cancel. And in this last one, the x's cancel. Let's see what's left over now. We have 5 times 4 for that first term, which is just 20. And then we have plus 7 times x, so 7x, equals negative 9 times 4. Don't lose that negative, so that's negative 36. And now we just have a regular equation. Subtracting 20 over to the other side, that's going to be negative 56. And then dividing both sides by 7, we have x equals negative 8. Now, did you check to see if this made anything undefined? We still have to do that. If I plug negative 8 into these x's, I don't have any zeros in denominators. So again, I've got a good answer here. So here's another example with two terms on one side. Pause the video and give this one a shot. So our LCD this time around, this 1, by the way, you could think of it as a fraction with an invisible 1 underneath. So really the only non-1 things, we have an x here and this x minus 5, and that's it. So I'm going to multiply all my numerators by x parentheses x minus 5. Now when I do this, Kind of the rookie move on this is to forget about the 1 here, but the 1 counts as a numerator because, again, we have that invisible divided by 0 going on. So the 1 gets an x minus 5, and so does the 8 and the 3 here. All right, let's go through and cancel stuff out. Nothing cancels out with the 1. There is really no non-1 denominator there to cancel. But the second fraction, the x minus 5s are going away, and this last fraction, the x's are gone. So cleaning this up a little bit and simplifying, we have an x times x is x squared, and x times negative 5 is negative 5x. And now this is a negative 8x right there. And over here we have equals, and now we distribute this 3, so that's 3x minus 15. This is a quadratic, so let's zero this thing out and see if we can factor it. So we have an x squared on the left, we'll just leave it there. Negative 5x minus 8x is negative 13x. Subtracting another 3x gives us negative 16x. And then let's add this 15 over to the left side. Well, let me try to factor this. Things that multiply to 15 and add up to negative 16, 1 and 15 actually works if they're both negative. So we have x minus 1 and x minus 15 equals 0. So zeroing each of these out, we then see that we have x equals 1 and x equals positive 15. Just double checking to make sure I'm not zeroing out any of my denominators. 1 minus 5 and 1 is fine. 15 minus 5 and 15 are also not a problem. So nothing undefined. We've got 2 more good answers. All right, we've got one more. This is definitely a true final boss battle for these sorts of questions. Pause the video. This is the most complex one yet, and give this a shot. Good luck. So I'm going to start this by trying to find an LCD, and before I can do that, I'm going to factor this second fraction, x squared minus 9. I can split that up into x plus 3 and x minus 3, which works out really nice. That's exactly what I have in those other denominators. So my LCD then has an x plus 3 and an x minus 3 in it. All right, well, let me multiply all my numerators by that LCD. So whole lot of writing, basically just what I had originally here with an x plus 3, x minus 3 next to each numerator. Let's go through and cancel some stuff. So the x minus 3's cancel in that first fraction. Over here now we have the x plus 3 and x minus 3 canceling. And lastly, we have x plus 3's canceling out. All right, time to clean it up and multiply and distribute. So we have 6x plus 18 equals, this is just 8x squared, so that's really nice, minus, let's see, negative 4x times x is negative 4x squared. Negative 4x times negative 3 is going to give us positive 12x, so careful with that double negative. Let's move everything over to one side now. I'll just leave the 8x squared over there. Actually, let me subtract the 4x squared from it, so that's a 4x squared now over on the right side. I've got a 12x over there already. I'm going to subtract the 6x from that, so that's going to be another 6x. And then let's subtract the 18 over to the right side to get negative 18. And then I'll just switch sides and put 0 over there. So this is a quadratic. It's a little bit more involved than the ones we've dealt with before. Before we jump right into AC method or whatever, I noticed that 4, 6, and negative 18 are all divisible by 2. So let me just go through and divide everything by 2 to make my life a little easier. So that'll be 2x squared plus 3x minus 9. And at this point, dealer's choice, you could use quadratic formula or you could try the AC method. I'm going to go the AC method. It's a little bit shorter if it works. So 2 times negative 9 gives me an AC value of negative 18. So I'm looking for things that multiply to negative 18 and add up to 3. 1 and 18 doesn't work. 2 and 9 doesn't work. 3 and 6 works if I have negative 3 and positive 6. So I'm going to split this up into negative 3x plus 6x. At this point, I'm going to factor these 4 terms by grouping. First 2 terms, I can take out an x. That leaves me with 2x minus 3. And for the last 2 terms, I can take a 3 out of both of those, leaving me again with 2x minus 3. So 2x minus 3 is my common factor that I can take out of all this, and then x plus 3 is the other factor. Setting each of these equal to 0 and solving, for this first one, if I add 3 and divide by 2, I've got 3 halves. And this next one, we have negative 3. Do either of these make anything undefined? Well, if I plug 3 halves into, let's just use the factored version of this, 3 halves minus or plus 3 is not going to give us 0 anywhere, so that's fine. However, negative 3, if I plug that in for the x plus 3, that zeroes out the second and the third fraction. If it zeroes out any of these, then that's a deal breaker. So because negative 3 makes our original equation undefined, we actually have to eliminate that as an extraneous root, and only 3 halves is a true answer for this one. So that's it for this one. Thanks for coming along on this journey. Till next time, Mr. Sutton signing off.